A general coding model just did something nobody expected. Z.ai says GLM-5.3 can compete with Claude Fable 5 on coding. But that is not the result getting everyone's attention. On a benchmark built from real software vulnerabilities, it reportedly scored higher than Anthropic's restricted cybersecurity model, Mythos 5. And GLM-5.3 was never designed as a dedicated cybersecurity model. So in this video, we'll see how a general coding model became this powerful and how close it really gets to Fable and Mythos, and why Z.ai is completing additional security tests before releasing the open weights. Because GLM 5.3 appears to be extremely good at finding vulnerabilities, but finding a weakness and turning it into a complete attack are two very different things. Let's begin with the result that makes GLM 5.3 so unusual. CyberGym is not a normal coding benchmark. It uses 1,507 real vulnerabilities taken from 188 open source projects, including OpenSSL, FFmpeg, and OpenCV. The model is given real software and asked to reproduce a known vulnerability. Its proof of concept must trigger the problem in the vulnerable version, but not in the patched version. So this is not a multiple choice security test. The model has to understand the code, find a real path to the bug, and prove that the problem exists. According to Z.ai, GLM 5.3 reached 84.5% on its CyberGym evaluation. Mythos 5 reached 83.8%, while GPT 5.6 Sol scored 83.6% in the same reported comparison. That puts GLM 5.3 at the top of Z.ai's table. These results were reported by Z.ai and have not yet been independently verified. But if they hold up, this is a major result. Mythos 5 is a cybersecurity version of Fable 5 with fewer safety limits. Only approved organizations can use it. GLM 5.3 is a general coding model planned for an open-weight release. And yet, on this test, it was reportedly even better at finding and confirming real software vulnerabilities. But this is where the headline needs some context. GLM 5.3 may be excellent at finding where a system is weak. That does not mean it can turn every weakness into a complete working attack. On ExploitBench, GLM 5.3 scored 54, Mythos scored 78. The gap becomes even clearer when the models are given more time to develop an attack. In a 2-hour evaluation, GLM 5.3 completed 105 tasks. Mythos completed 180. After 6 hours, GLM 5.3 reached 130 tasks. Mythos reached 247. The simple version is this. GLM 5.3 may be better at finding the door. Mythos is still much better at opening it. Z.ai says the model's current strength is in the early part of the process, discovering and verifying vulnerabilities. Deeper exploitation still needs improvement. The CyberGym result does not prove that GLM 5.3 has replaced Anthropic's specialized cyber model. It shows that a general coding model is already remarkably good at one of the hardest parts of security research. So how did a normal coding model become this good at cybersecurity? GLM 5.3 does not use a completely new base model. It uses the same base as GLM 5.2. According to Z.ai, all of the major improvements came from post-training. In simple terms, the company did not just make the model larger. It taught the existing model to reason for longer, use tools more effectively, recover from mistakes, and finish harder tasks. The improvement is easy to see in its coding results. On Terminal Bench 3, its score increased more than 6 times. On Deep SWE, it improved by almost 45%. These benchmarks test whether the model can solve real software tasks, use tools, and continue working when something goes wrong. A normal chatbot can produce a convincing answer and stop. A coding agent has to stay inside the task. It runs commands, reads the output, notices when its first idea fails, and tries a different approach. The longer that process continues, the more chances the model has to make a mistake. So improving on these tests is not only about writing better code. It is about remaining useful across an entire chain of decisions. They decide whether an agent can fix one small function or keep working across a real project. Z.ai also says GLM 5.3 improved by 50% over GLM 5.2 on the company's own coding benchmark. That is a huge change for a model built on the same base. Finding a vulnerability often requires the same skills as solving a difficult software problem. Search a large code base, understand how files connect, form a theory, test it, inspect the result, and correct yourself. Those skills can help an AI build software, but they can also help it find where software breaks. So as coding models become better at completing real projects, advanced security abilities may come with them automatically. Better security results are only one part of the story. Z.ai also says GLM-5.3's general coding and agent abilities are on par with Claude Fable 5. That is a major claim. Fable is one of the strongest models for coding, tool use, and long technical tasks. If GLM-5.3 is genuinely close, it could become a serious open-weight alternative to one of the best closed coding systems. But Fable level does not mean the two models will feel identical in every project. One may be better at building a new application, another may be more reliable at debugging. One may follow instructions more carefully, while another works faster or uses fewer tokens. The comparison also comes from Z.ai's own evaluation. We still need independent testing before saying GLM 5.3 has replaced Fable. For now, the safer conclusion is that GLM 5.3 has entered the same conversation. What do you think? Should a model with this level of cybersecurity ability be released as open weights, or should its most powerful security features require verified access? Tell me in the comments. Once a model becomes this good at finding vulnerabilities, releasing its weights is no longer a normal product decision. The GLM 5.3 weights are not public at the time of the script. Reuters reports that Z.ai plans to release them after roughly 2 weeks of additional security evaluations. It is important not to describe this as a delay. There is no confirmed earlier release date that the company missed. Z.ai is testing the model before publishing the weights. The company says it is screening risky requests, monitoring the work the model performs, and training it to reject harmful tasks. Those protections are easier to maintain when the model runs through an online service. The provider can block users, inspect unusual activity, and update its safeguards. Open weights change that situation. Once people can download and modify the model, many of those controls can be removed. Z.ai has suggested that the most sensitive cybersecurity abilities may require trusted or verified access. But there is another side to this argument. An open model could also become a powerful defensive tool. Security teams could run it privately, audit important open-source projects, and find vulnerabilities before attackers discover them. Z.ai calls this idea an open-source shield. The same ability can help defenders and attackers. That is what makes this release both exciting and difficult. Do you keep the model closed and limit who can use it? Or do you release it so developers and security researchers can use the same technology to protect their software? There is no simple answer. But GLM 5.3 shows that this is no longer a future problem. It is happening now. GLM 5.3 is already available through Z.ai's coding plan and is integrated into the company's coding tools. It supports a 1 million token context window, allowing it to work with very large code bases and long sessions. Its maximum output is 128K tokens. However, the public API was still listed as coming soon. Official API pricing had not been announced, and the downloadable weights were not yet available, so check the current status before you plan around it. Access details may change quickly. So, is the hacker model really here? For finding and confirming software vulnerabilities, the answer may be yes. GLM 5.3 reportedly leads Mythos 5 on CyberGym, improved dramatically over GLM 5.2, and reaches what Z.ai describes as Fable-level general coding performance. That is remarkable for a general model using the same base as its previous version, but GLM 5.3 is not a complete replacement for Mythos. When the task moves from discovering a bug to building a complete exploit, Anthropic's specialized model still has a large advantage. So the real story is not that GLM 5.3 is a perfect hacking AI. The real story is that a general coding model is already this close, and if these abilities came mainly from better post-training, longer tasks, and stronger tool use, the next generation could go much further. GLM 5.3 may be remembered as the moment advanced cybersecurity stopped being a special feature and became a normal ability of powerful coding agents. If you want more clear breakdowns of the newest AI models without the hype, subscribe. And when the weights are released, we can test what GLM 5.3 actually does outside the company's own benchmarks.